Welcome back, guys. In today's video, I'll be covering limiting reagent. Now we're going to walk through this limiting reagent problem with this balanced chemical equation. But before we do so, let's talk about what limiting reagent is and what it means. Okay, so to do that, let's use an analogy. So imagine you are trying to make pizza, right? And with this pizza, you're going to have dough and you're going to have cheese. It's a very basic pizza with just dough and cheese. Now imagine you have basically unlimited dough, right? Your company just got a big shipment of dough, so you have piles and piles of dough stored away that you can use to make these pizzas. Now imagine that your pizza company is very short on cheese, right? You guys have 3 or 4 bags of cheese left, but you're definitely running low on cheese. Now, when you go to make those pizzas, right, you need to make sure that there is dough and cheese. You can't make a pizza without one or the other, right? So you can't make a pizza with just dough, and you can't make a pizza with just cheese. Now, when you go to make those pizzas for the day, right, you're going to use the dough and you're going to use the cheese. However, what you're going to see is you're going to run out of the cheese before you run out of the dough. Now that's going to make cheese your limiting reagent, right? That cheese running out first is going to limit how many pizzas you can make, right? You have enough dough to make a lot of pizzas. However, that limited amount of cheese is going to limit how many pizzas you can make, okay? So if we use that and apply it to this chemical equation, what we want to figure out is if we run this reaction, right, is zinc or our HF going to limit how much of our products we're going to make, right? Once we figure out what's going to limit or what's going to run out first, we can say that zinc or HF will be our limiting reagent, okay? So now we have a better understanding of what limiting reagent is. Let's tackle this practice problem. So in this practice problem, it says that 50 grams of zinc reacts with 35 grams of HF. Determine the limiting reagent, and we want to know how many grams of ZnF2, right, zinc fluoride, form. Okay, so how are we going to do this? Well, the first thing we want to do in a problem like this is get moles of our reactants, right? Grams do not help us much in a problem like this. We want to get moles, and it'll make sense in a second. So we're going to get our 50 grams of zinc into moles, right, by dividing by the molar mass, right? And the molar mass of zinc is 65.38. Okay, so that will give us the moles of zinc. And let's get the moles of our HF, right? We have 35 grams of HF and 1 mole of HF is going to be, well, if we add this up, right, we have fluorine, which is 19, and hydrogen, which is 1, right? I rounded here. So it's going to be about 20 grams per mole. Okay. Now, if we do this math out, right, we have 50 grams of zinc divided by the molar mass. That's going to give us 0.765 moles of zinc, okay? And we're going to have 1.75 moles of HF. Now, a big mistake I see students make often is they get here and they say, okay, well, we have less zinc, so it must be our limiting reagent. Now, do not make that mistake, right? You cannot determine the limiting reagent simply off how much of something you have. You need to see how much product you're going to make in order to determine your limiting reagent, right? So back to our pizza example, you can't just say cheese or dough is the limiting reagent right away. You would need to see how many pizzas you would make with that given amount of cheese and given that amount of dough. Now, how are we going to do this? Well, what we're going to do is we're going to take our moles of each thing, right? I'm going to write that over here. So we have 0.765 moles of zinc. We have 1.75 moles of HF, right? And what we're going to do is we're going to pick a product, right? It doesn't matter what product we pick. I'm going to pick ZnF2, right? And we're going to use these values to see how much zinc fluoride we can make if we use zinc and if we used HF, right? So let's erase this and give ourselves some room to work and determine our limiting reagent. So if we assume zinc is our limiting reagent, right, and we're going to make the assumption that HF is our limiting reagent next, but let's assume this is our limiting reagent right now. So in that case, it would be 0.765 moles of zinc. There is one zinc, right? We're using stoichiometry here. Make sure to check out my video on stoichiometry if you need a refresher. There's 1 mole of zinc for every 1 ZnF2, right? This is a 1-to-1 ratio. So this would produce 0.765 moles of ZnF2. Okay? So let's see how many moles of ZnF2 we can make with HF. So 1.75 moles of HF. Remember, there are 2 HF for every 1 ZnF2. Okay? So it's important to realize, right, in our original values, right, we can't just say zinc is the limiting reagent right away, right, because the stoichiometry might mess with these numbers, right? We could actually end up making less ZnF2. However, let's see if that's the case. Well, when we divide this out, we're going to see that we get 0.875 moles of ZnF2. Okay, so what's our limiting reagent here? Our limiting reagent is going to be zinc, and that's because we produce 0.765 moles of ZnF2. Okay, so when we see this number right here, right, this is actually a theoretical number, right? We are actually not going to produce 0.875 moles of ZnF2 with the given starting material that we have. Now, if we had unlimited zinc, right, and we had 1.75 moles of HF, we could make 0.875 moles of ZnF2, right? That would make HF the limiting reagent. However, we see that we're going to run out of this zinc first, right? So only if we had unlimited zinc could we make that amount of ZnF2. So our limiting reagent, right, is zinc. Okay? How many grams of ZnF2 are going to form? So when it asks how much of something are going to form, you need to use your limiting reagent to calculate that, right? So we actually don't care about this when we go to solve for this, and we can see that we're going to make 0.765 moles of ZnF2, right? So to get that to grams, right, give myself some room here, 0.765 moles of ZnF2, right? 1 mole of ZnF2, right? We have to multiply by the molar mass here, which is 103.38. Okay, and we multiply this out, we get 79.09 grams. Okay, so this is how you walk through a limiting reagent problem. Remember, you have to use the stoichiometry, right? Find how much of your product you're going to make, determine your limiting reagent, right, and calculate how much of that product that you're going to form. Hopefully you enjoyed this video, and make sure to check out the channel for more videos.